The next step in Alpha Office's transformation will be a Kubernetes REST service deployment. As Alpha Office's DevOps engineer, Derek lives in a world of constant change. In his short tenure, he has done his best to embrace the DevOps revolution. He hopes to improve the process efficiency by leveraging emerging technologies and provide his staff more time to innovate. The modernization effort initiated by his CTO gives him a chance to implement some of his ideas, but also presents several new challenges. To date, neither he or his staff have a firm grasp on container deployment strategies. He has heard they are a bit challenging to install and configure. He also has his doubts about open source software meeting the company's security, scalability, and geodiversity requirements. With that said, he's willing to give it a shot. Today, for the first time ever, Derek will explore Kubernetes and determine a cloud provider he can pilot for the modernization effort. Kubernetes is a portable, extensible open-source platform for managing containerized workloads and services. It was originally developed by Google and open-sourced in 2014. It consists of several key components, including deployment, pods, replica sets, and services. Deployments verify that a container, or a set of containers, are up and running. Deployments represent the highest level abstraction of an application inside Kubernetes and manage several important subcomponents. The first is called a pod. Pods are logical groupings of Docker containers that make up a single microservice, along with their critical resources such as networking and storage configurations. The product catalog microservice created by Christian would be an example of a pod that could run on Kubernetes. To ensure pods are properly up and running at all times, Kubernetes deployments leverage replica sets. Replica sets are designed to quickly create or destroy instances of our pods as required to scale out or scale in the microservice. The final Kubernetes component that Derek will learn about today are services. Services coordinate and manage network traffic across multiple pods, providing a solid, high-availability framework while enabling you to scale out your application as the business requires. After learning more, it's clear that Kubernetes is a technical fit to deploy, manage, and scale microservices at Alpha Office. All that is left to learn is a little more about how this is accomplished in the cloud leveraging Oracle Containers, or OKE. Oracle Containers is a fully managed, scalable service that you can use to deploy your containerized applications to the cloud. It is an unmodified copy of the open source version of Kubernetes, running directly on top of blocks of computational power, storage, and networking inside the Oracle Cloud infrastructure. Oracle Containers leverages the Oracle Cloud Infrastructure identity and access management out of the box to provide authentication and authorization required to meet Alpha Office's security needs. Alongside OKE sits the Oracle Cloud Infrastructure Registry, OCIR. OCIR makes it easy for REST developers like Christian to store, share, and manage versions of her code inside her Docker container. With all the research in place, Derek is ready to get started. In Lab 300, you will assume the role of Derek and provision a Kubernetes cluster on OCI. Next, you will store the Docker image from Lab 200 in Oracle Cloud Infrastructure Repository, also known as OCIR. Finally, you'll deploy your microservice inside your Kubernetes cluster and validate application deployment by calling the REST service.
Okay, let's get started with Lab 300. Once logged into the OCI console, let's navigate to Identity and Policies. For this policy, we want to be in the root compartment of your account. Let's make sure you navigate to that compartment. Let's select the PSM root policy, and let's click Add Policy Statement. And click Add Statement. Now this policy will allow the Oracle Managed Kubernetes environment to spin up OCI compute instances as needed. Now that the policy has been created, let's navigate to Developer Services, Container Services. And let's navigate back to our mono to micro compartment, and let's create our Kubernetes cluster. Click the Create Cluster. Let's leave the cluster name as a default along with the version. Let's go with the Quick Create option. And finally, let's scroll down and click Create. Let's click Close. And now you will see that the Kubernetes cluster is in the status of creating. Now while this is creating, let's move back over to our OCI virtual environment that we created earlier for Docker. And let's install and configure the Oracle Cloud Infrastructure CLI. Our first step is to download and install it by running the following bash command. Let's accept the defaults for the directory, the OCI executable, the OCI scripts, let's enter yes to modify the path, accept the default for bash RC, and now the OCI CLI has been installed. Our next step is to configure it. In order to configure it, we'll need some information from our OCI console. The first piece of information is our user's OCID. So let's navigate to Identity Users. Let's click the View Users Details. And let's click the Copy to copy the OCID for the user. Let's navigate back to the terminal window. And let's issue the command OCI setup config. Let's accept the defaults for the config location. Now let's paste that OCID for the user that we copied earlier. It's now going to ask us for our tenancies OCID. Let's navigate back to the OCI console. Let's click the user icon up in the right-hand corner and pick tenancy. Here you will see the tenancy information. Let's click the copy button. Let's move back over to the OCI setup config script. Let's copy and paste the tenancy ID. Now for this workshop, we're using the region of US Phoenix 1. So let's enter US Phoenix 1 as the region. We do want to generate an RSA key pair, so let's say yes. Let's accept the defaults for the location of the keys, along with the name. We'll leave it blank for no passphrase. Now we're going to display the contents of the OCI public key that was just generated. We're going to copy that. And we're going to navigate back to the OCI console, to the user, Identity Users. We're going to select our user that we selected earlier. Let's scroll down, click API keys on the left. Let's click Add Public Key. Let's paste the contents of the key we just copied and click Add. Let's go back to the OCI OKE cluster and let's click on the Access Kubernetes button. Here it's going to give us a couple commands that we want to execute within our OCI VM. So let's issue the first command, which is the make directory kube. Let's jump back over to the OCI console and copy the second command. This command is going to generate a kube config file that we'll use later in the workshop. So let's copy that command and issue that. Now you'll see that a kube config file has been generated under the kube directory. We're now going to display that file, and we're going to copy the contents of that file and save it in a text file within the Jumpstart VNC client. Not to be confused with the OCI VM, we're going to save this within the Jumpstart VNC client. So let's open up a Notepad document and let's save this under the home directory, and let's call it kube config. Now that the kube config file has been saved off, we're now going to navigate back to identity users, and we're going to generate an authorization token for our user. So let's click auth tokens and click generate token. Let's enter a description. Click generate token. It's very important that you click copy here at this point and save it off. We're going to use this token to log into the Oracle OCIR registry and push our Docker image up to the OCI registry. So now let's navigate back to our OCI VM, and let's issue the following Docker login command. Let's use our authorization token we just generated as a password. Now you'll see that we are logged in successfully to the OCIR repository. Our next step is to push our Docker image that we generated earlier. Our first step to do that is to tag it with the proper cloud account, issuing the docker tag command. Once tagged, we can issue the docker push command, and this will upload the image into the OCIR. Once it's complete, we can navigate back over to Developer Services, Registry. We can expand the registry and see the image we just pushed. While we're here, let's copy off the pull command. We're going to use that later in the Kubernetes dashboard. We now want to make our repository public. So let's click on the repository alpha office-rest, click Actions, Change to Public. Now that our image is pushed up to OCIR, we now want to download and install kubecontrol into our Jumpstart client image, the one that you access through VNC Viewer. So once the kubecontrol is downloaded, let's set a couple environment variables for where the kubeconfig command file is. Now that the kubeconfig file is defined, let's issue a couple kubecontrol commands. The first one is cluster information. Here you'll see information regarding the Kubernetes cluster. Our next command is get nodes. This shows that there are 2 nodes running in our Kubernetes cluster. Now that we've verified that we can communicate with Kubernetes, let's set up a proxy. This will allow us to access our Kubernetes cluster through the Kubernetes dashboard. So let's access the dashboard URL. Here it's going to again ask us for our kube config file. So let's navigate out to our home directory and pick the kube config file. Click sign in. At this point, we're ready to deploy our Alpha Office REST application. So let's click create an app. Let's give it the name of Alpha Office. The container image that we're going to use is the same one that we pushed to the OCI registry. You can use your Docker pull command that you copied earlier to paste into there. We want to make our service external, and we want to open up the port 80 with a target port of 8080. Let's click deploy. This will now deploy our image sitting in OCIR into a Kubernetes cluster. After a few minutes, you'll see that the deployments are ready and 100% available. We can go in Discovery Load Balancing. We can see our Alpha Office REST service. We can click on the external endpoint. And this will open up a new tab and show that our Glassfish server is running. At this point, we can test out our Alpha Office REST by completing the REST call URL. Here you will see that it returns the products available in the product catalog. We're now going to exit out of the kube control proxy, and we're going to test our REST service using the command line. So let's do the kube control get pods and get the name of our pod that was created. Let's copy that. Let's issue the following kube control execute against our container, and we'll see that it will return the results for product 1050. And that concludes lab 300. On to 400 now.